Hi everyone! In the previous video, we managed to hear some voices from within the wire, but the unit itself that's playing those voices has some pretty big issues. So in this video, we're going to troubleshoot this device right here, get it playing the wire properly, and listen to some more of those voices. Let's get started. In the previous video, I managed to patch things up with some rubber bands, so I used them as belts, and we could hear some audio from the two spinning reels of wire here in the actual vacuum tube using the Carlson Ultra Probe here. So what I'll do is I'll turn this back on again. Actually, I'll turn the volume up here quickly. So this is a device that'll listen into components, all right? So you can hear that buzzing that you hear is the power supply hum. The filters in this are bad. I'll talk about that in a moment. So if I turn this on,
someone else in it will do the job at our bidding. So yeah, possibly good. I'm not too worried about that one phase of it because on a volunteer basis.
So we can actually hear voices coming off of this wire on the front of the machine right now. All right, so now what we did is I tacked in some capacitors on the bottom side of this device here, and that cleaned up the hum. So I'll tack in those capacitors now, and from that point we'll move on to the next step to see if we can actually get this device here playing the audio out of a speaker so we can really listen to what they're saying. I've tacked some filter capacitors into circuit here. Now, by no means is this a restoration or a repair video. This is simply a troubleshooting video. In order to replace filter capacitors in any device, the old filter capacitors need to be completely electrically removed from the circuit. Now, it's okay to leave the can in there as long as it's not electrically attached to anything. So, the can can be, grounded to the chassis, but all the rest of the terminals need to be removed. For troubleshooting purposes only, I've tacked this in so that we can move on to the next point and find out why there is no audio coming out of the speaker in this thing whatsoever. The audio is at 10 and the tone is at 10, but the speaker is just absolutely silent. So there's definitely a problem in the audio section. So at this point here is where we basically stopped in the last video, and I had the Ultra Probe here right by this capacitor, and we were listening to audio from this capacitor. So let's see if we can hear audio again. I'll turn this on. All right, and I'll put this beside this capacitor here. And let's see if we can hear anything now without all of that horrible hum. I got to make sure that I only go this way to listen. This side says record. The last thing I want to do is record over anything that's on this. All right, so here we go.
End result of it will be, and I enjoy saying this because being a CCFer, is that you will naturally evolve into the type of government that is presently in the Scandinavian countries and to a large degree in Great Britain all over.
So we have relatively clear audio coming out of this capacitor, and this is one of the coupling capacitors in the audio stage. But yet again, if I shut this off and completely remove this, as you can see, the audio is at 10, right at its max. The tone is right at its max, but the machine is dead silent aside from mechanical noise, right? The bumping of the hardened rubber reels in the back. And rubber wheels in the back that are turning, right? You can hear the flat spots and stuff like that. So the next thing to do is to try and get some decent sounding audio out of a speaker. So let's find out what is actually wrong with this and why this speaker is just sitting here silent. Oh yeah, I should mention, if you are wanting to build one of these Carlson Ultra Probes for yourself, all the plans, everything is in my electronics course on Patreon. So the plans to build the box and the actual probe itself, it's built out of everyday parts and pieces. This is a desoldering tool that's turned into a probe shell. This is a non-contact style probe, so it doesn't actually electrically touch anything. It's all insulated. This is a piece of coax, and it's listening from a piece of wire. So everything that you're hearing in here is listening from a piece of wire. It's so sensitive, if you tap the wire, it'll actually hear the wire. So to give you an example, So So it has a lot of applications. I even do an example of where this device will listen to music playing through my body. That video itself is in my Patreon electronics course as I was building this and putting this together and giving everybody examples of how incredibly sensitive this is. No kidding. It was actually listening to music playing through my body. It's one of the videos up there. Anyways, check it out if you're interested in putting this device together for yourself. All right, back to the troubleshooting. The audio that we were listening to using the Carlson Ultra Probe, that's not to be confused with the Super Probe. This one is the Ultra Probe. The Super Probe is the old one. But anyways, the Ultra Probe was listening to the audio on this capacitor right here, and this capacitor attaches to the plate of the preamplifier tube here. Now that preamplifier tube is this one right here, and this would be that capacitor. So this attaches the plate to the grid of the output tube here. Now, we have no audio. We have audio here, but this is what drives the speaker itself, this whole section here. So it has to be within this section where the issue lies. So if we see the lead coming off of this end of the cap, it runs over here and then through this grommet here. Now keep in mind that this thing is unplugged and all the capacitors are safely discharged. This green wire runs over here to this tube. And obviously that's going to attach to the control grid of the 6V6 tube. This is that tube right here that drives the audio transformer. Now in the previous video we saw that the grid of this tube looked like it was glowing red. I'll see if I can focus in on that right now and show you that again. This tube here is the tube that drives the audio output transformer, and then of course that audio output transformer drives the speaker inside this unit here. Now there's something very wrong in that circuit because this tube is acting in a way that it definitely should not. And we can compare this tube to this tube right here. They're both the same tube, 6V6, and I'll show you the differences in what's actually going on. So I'll turn on the unit right now and let everything warm up. So you can see the cathodes in the rectifier tube warm up here. So the rectifier tube, these two orange things you see in here are the cathodes. This is known as a directly heated vacuum tube. These two tubes here are known as indirectly heated vacuum tubes. So the filament itself is the cathode in here. The filament in this tube has to heat a cathode pipe, that little round pipe, in order for this tube to come into emission. So this tube here will come into emission way quicker than these. Now, if you look at this tube here, you'll see the internal structure inside of this tube is starting to glow orange. You see how this is all lit up here, where this is all nice and dark over here, on this side right over here? So you can just see the cathode light here, but this is nice and dark. Now, if you look very closely, you'll see the screen grid posts over here. This is the control grid. This is where the audio goes in to those two little lines right there. Right next to it is the screen grid, and you'll notice that those posts are glowing orange. And if you look inside this little crack in the tube here, you'll see that very thin wire in there. That's the actual grid wound around those two outer posts is glowing orange hot. What does that tell us? Well, that tells us that the plate circuit inside this tube is most likely disconnected somehow. So whether it's a bad solder joint or it could be an open connection in the audio transformer that's causing this, what's happening is now the screen grid is trying to do the job of the plate. And of course, the screen can't take that. So what it does is it starts to glow orange, right? Because the electrons from the cathode are now bombarding those wires and it's causing the wires to heat up. So you see these little posts here are orange hot, not this one here, but the one right next to it. I'll shut the tube off and you'll see that that will start to calm down, whereas you can see these are just nice and cool in here, right? So I'll shut it off. Look at those posts. They are orange hot. They should be the same color as the rest of them. They shouldn't be glowing at all. So that tells us that we have a really big problem within the audio circuit itself, and that's what we need to look for. Now, I know many of you are probably saying, shut it off, you're gonna hurt the vacuum tube. I'm not worried about it. I have a lot of them, and I'm doing this in the name of science. I'm now ready to start troubleshooting the audio power amplifier in this unit. And the tube on the top side of the chassis with the issues is this one right here. Now, as mentioned before, the screen grid is not supposed to glow, and that's this connection right here. So the center set of dotted lines inside this vacuum tube is known as the screen grid. The part of the vacuum tube that is supposed to glow is the heater and the cathode, and that's this little section down here. Again, these are known as indirectly heated vacuum tubes. So this one, this one, this one, and this one. This tube here is directly heated, and that's why you just see the filament drawn inside the vacuum tube. You don't actually see a cathode drawn over top of the filament like you do on these tubes right here. I'll talk more about all of this stuff here in the future. Now, if we follow the actual screen grid line, we see that it runs down here and it goes directly right back into the power supply. So we'll have full B+, or in modern speak, full rail voltage on the screen all the time. We'll also notice that that connection runs over here to the audio output transformer's primary winding. On this side of the primary winding, it runs up over to the anode or to the plate of the vacuum tube. Now, as I mentioned earlier, the screen grid will normally glow if the connection to the plate or anode is missing, or if the plate or anode voltage is missing. What's happening is the screen grid is trying to do the job of the anode and it just can't deal with it. And that's why it's starting to glow orange inside the actual tube. So the electrons are hitting the actual screen grid basically, and it's causing it to glow orange where they should be attracted to the actual plate of the vacuum tube. All right, so they should be, flying through. Of course, some of them will hit the actual screen itself, but most of them should be going to the plate. In this case, most of them are, well, basically all of them are going over to the screen grid. The bottom set of dotted lines you see here is the control grid of the tube that controls the actual vacuum tubes. That's where the audio comes into the audio output tube here. So if you were to look at this like a FET, that would be the gate of a FET, or if you were to look at this like the transistor, this would be the actual base of a transistor. Tubes are closer to the way FETs actually operate. Again, I'll talk more about that in other videos here in the future. The grid that you see on the top side here that's just below the anode is known as a beam forming plate. In most pentode vacuum tubes, this is known as a suppressor grid, and what it does is it suppresses secondary emission. So what happens is the actual electrons fly off the cathode with such high velocity, or hit the plate with such high velocity, that they bounce off the actual anode and come back into the tube, and they cause a thing called secondary emission. So what happens is the suppressor grid in a normal vacuum tube suppresses that action. In this particular tube, this could normally be classified as actually a beam tetrode tube. And these dotted lines on the top here are known as beam forming plates or collimating plates. And what ends up happening is the electrons that fly off the actual cathode get collimated into two columns. And they'll hit the plate structure inside the vacuum tube on two sides. Again, I'll talk more about all of that in future videos. Stick around. This is the kind of stuff that I do. I teach people all about this, modern and antique electronics alike. And again, I have an actual electronics course on Patreon if you're interested in the real in-depth stuff in this type of thing. So what's happening here is I'll have full rail voltage or full B+ on this, and chances are I'm missing that on this point here. This connection is pin 4 of the vacuum tube. This connection is pin 3. And this connection here in the vacuum tube, which is the control grid, is pin 5. And I'll talk more about that in just a little bit. So I will test pin 4 first, which should have rail voltage on it, the part of the tube that is not supposed to be glowing. Now keep in mind, if you're following along, you're doing so at your own risk. Know that all vacuum tube gear has elevated voltages inside of it. So let me do the testing. I'll do all the testing. You sit back and just watch, all right? If you're interested in learning more about all of the elevated voltages and stuff like that, I talk a lot about that on this particular channel, all right? And of course, again, in my electronics course. All right, so now I'm going to test this point right here, all right? So what I'll do is I'll go over here, and I'm going to touch that portion with my probe. I'm going to show you the voltmeter, and I'll tell you about what's going on here. So I'll just move the camera into that so you can see that, hopefully nice and clear. Get that right up into focus. All right. So what I'll do is I will attach this to the actual screen grid first, and we'll take a look at that. All right, so here we go. That's the screen grid. So that's the B plus on there, 322.5 volts, right, or around, right? The bobbing around you see in the voltage is my soldering iron on the bench turning on and off. It's causing that to move around, all right? So 322 on the screen. So again, that's at this point right here. Now the point of interest is this point right here. Let's see if we have any voltage on the plate. And that's what's on the plate. Actually minus 11 volts, so it's completely open. So what does that mean? That's right at the actual vacuum tube. So what I'll do is I'll show you right here. That's at this point right here. All right, so that connects directly to this device right here, which is the audio output transformer. So what does that tell us? This transformer is bad. The primary winding in the audio transformer, almost the heart of this unit, has gone bad. So what I'm going to have to do now is grab another audio transformer, tack it into the circuit, and run an external speaker. And let's see if we can hear any audio out of that external speaker. I found an audio transformer in my junk box, and I've temporarily mounted it to the bottom portion of the chassis here. So these screw holes normally hold the bottom plate on here. Right now I'm just using one of the screw holes to hold the case of the transformer so it just doesn't roll around. I don't want to risk pulling the leads out of this transformer here. They just go behind this paper here, and they're usually pretty fragile. For those of you with good eyes, you'll notice that this is a push-pull type transformer, and I am running this transformer end to end in this circuit here, and I have the center tap capped off right here just with a piece of insulated tubing. Now before I power this thing up and attach speakers to this audio transformer, I don't want to burn this one out. So what burnt the original audio transformer out? Well, it's a very common thing. It's these capacitors, these wax capacitors all fail and they all become very leaky. So what ends up happening is, this is the audio coupling capacitor, this one right here, and that's the one that we were listening to right here. All right, that's this cap right here. And what that does is that's taking the plate potential, all right, so we have the plate voltage here, and when this capacitor fails, what they do is they actually turn into resistors. So you can actually picture a parallel resistor across that. And what that does is that takes the plate voltage and puts it on the grid of this vacuum tube, turning this tube on more. So it's causing the tube to conduct heavy. And what happens when this conducts heavy? Well, it draws heavy current. What does it draw heavy current through? The primary winding of this transformer. And that's the reason the primary has failed. So the reason this transformer has failed is going to be because of this coupling cap. And again, that coupling cap is this one right here, the one that we were listening to. So that will have to be taken out of circuit and replaced. Either that, or what I'll end up doing is I'll end up risking this audio transformer, and I definitely don't want to do that. So I'll remove this from circuit, and we should be able to power this thing up and take a listen. I've desoldered one end of this capacitor here and just lifted it out of circuit. I've tacked in a new capacitor across those 2 points right there so that I do not damage this new transformer. Did this capacitor actually damage this transformer? Yes, absolutely it did. So what I'll do is I'll show you here on this tester how bad this cap is. So when I turn this tester on here, what should happen is this should zip through the red scale, zip through the yellow scale, and turn green. So that whole process may be taking about a maximum of 7 to 10 seconds. All right. So if we turn this on right now, turn this light off here. Look at how bad that is. It's not even moving through the red scale. So incredibly slow. So that should have been green by now. So it should have gone all the way down, started over again, gone yellow, and then this little lamp would have turned green, indicating that it's low leakage. So what this thing does is it looks for a thing called parallel resistance. So it's looking for, you could picture a fictitious resistor across this capacitor. All of these capacitors fail the same way, basically. What happens is the paper inside goes acidic. This is known as a paper and foil capacitor, not paper in oil. So the paper inside of this one here is going acidic, basically like the pages of an old book. It's turning yellow, and it becomes slightly conductive. And what ends up happening is when it becomes slightly conductive, it passes DC across this, and it causes the audio output tube to draw heavy current, and then again, of course, destroying the transformer. And that's definitely what this has done. So I'll give you an example here with a new capacitor. This is a new cap across the same device. So, all right, so here's a new cap. The same cap that's in here right now, same value as that one. All right, so what I'll do is I'll turn this on. You'll see how quickly that moves down. That's how the capacitor should move down. You'll see it zip through the orange scale or the yellow scale here very quickly. And then that'll go green, telling me that it's okay. All right. This is another device that I've designed and released on Patreon if you're interested in building this low voltage leakage tester for capacitors. Very handy to have around, especially for capacitors that you don't recognize. If it's maybe a wax cap hiding in something else, or a paper and foil cap hiding in a different type of capacitor shell, that'll very easily tell you that. And of course, if you're repairing guitar amps and everything, that's an absolutely important device to have on your bench. All right, are we going to hear anything? I have the speaker set up beside this, and everything seems to fit in here. So what I'll do is I'll reach over here and turn on the isolation transformer and current limited variac supply. If you can see that jewel lamp is on in the front there. Got to wait a few moments for the tubes to warm up. I don't know if the speaker's humming at all. It is. That's a good sign. There is life there. All right, let's take a listen. What do you think? I turned the volume down, by the way, so just so I don't start off with it at the max. So here we go.
Assess our social requirements and what we can do about them through our present machinery or other similar to it. Gordon stressed the need for a reconstruction of society as a basic cause, and but he also expressed a fear, I think, of big government, which our last speaker has not agreed with. In fact, I quoted the Sully as expressing approval of what he termed a paternalistic sort of government. Here I think we have a good mixture of views for some discussion. Yes, but they could be developed, if developed in certain directions. These views would provide basis for some serious consideration on different lines.
It's amazing how good that sounds.
Well, can we take a comment at each other? I think so, unless it's well, I want to first get a chance at my friends here, and I think we should deal with what we raised with each other. Mr. Sullivan.
Sounds like somebody fumbling with a mic stand.
I think that because I fear what might be called big government, I don't fear it in perhaps the sense he thinks. I fear this, that people will their responsibility, their social responsibility, onto government and quietly forget the fact that they're part of the community themselves. And I feel that the community is needed by these people. You as individuals are needed by these people. That one of the causes of their problem is their rejection by the community and the absent-mindedness of the community of these problems.
You know, this could go on and on and on. So I know some of you said that you'd like to hear all of the entire thing. Well, you know, this would probably end up playing for who knows, an hour, who knows, something like that. So I'll have to figure out a way to maybe digitize that. And anyways, stay posted for that and for what I'm going to show you here in just a moment. Stay tuned. I found another reel. This one says 1949 instructions complete with some cryptic writing on the other portion of the reel. It's in a shielded metal can, so it should be okay. So definitely subscribe and tap the bell symbol. That way you'll be notified as soon as I post a brand new video. There'll be many electronics videos coming on this channel. Lots of electronic troubleshooting, repairs, teardown videos, all of that great stuff coming here. So if you're enjoying these videos, you can let me know by giving me a big thumbs up. If you're interested in the plans for the Ultra Probe, definitely check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comment section. So if you click on that link, it'll take you right there. You can check it all out. All right, until next time, take care. Bye for now.